So in this video, we'll be discussing about feature engineering. So this is the first lecture based on feature engineering. And in this particular video, we'll be looking at the theoretical aspects of feature engineering and not the practical aspect. So we'll be looking at what are the steps we might need to follow in order to achieve feature engineering, right? So feature engineering is one of the most important process or procedures we would need to follow before going into machine learning aspect. So before you apply any machine learning algorithm, you need to you need to do this feature engineering process. So in this particular video, we'll be looking at what are the steps you might need to follow in order to make your data set clean and clear to apply any particular ML model, right? So the topic for today is feature engineering, and we will be looking at what are the steps we might need to follow so that it will be very clear for us to apply any ML algorithm. So basically, what most of the people who worked in industry and what is available online, they say that it almost takes about 30% of your time to complete feature engineering, right? So what that means is before you work on any machine learning project or when you work on any machine learning project, you almost spend 30% of your time doing feature engineering. So what are the things we need to follow or what are the things we need to do while performing feature engineering? So the first thing primarily is you need to have good knowledge on the basic Python libraries. Python libraries. Primarily, you should be knowing NumPy. You should be knowing pandas. You should be knowing matplotlib and seaborn. So you should have a good, at least good basic knowledge on what are the functionalities each of these libraries are used. Where do we use them? You should know as much as functions as possible. Although it is not possible to remember all of the functionalities of each libraries because each of them have huge functionalities, right? But you should be knowing the basic functionalities so that it will be easy for you and you don't need to Google everything again and again, right? So Matplotlib and Seaborn is basically for data visualization, and Pandas and NumPy will be purely working or doing things on the data set. So primarily data set manipulation, you can say. So the first thing, you need to have a good knowledge on the Python libraries. So you should know NumPy, Pandas, Matplotlib, and Seaborn. The second thing which involves feature engineering or the step is EDA. And EDA will be, I think, would have been covered by now. So EDA is nothing but exploratory data analysis. So exploratory data analysis is, as the name suggests, EDA, exploratory. You're going to start exploring your data set. So you'll be looking at what are the columns, what are the different features I have, what are the statistical things which I can, come out with the features, what is the mean, what is the median, what are the different functionalities using pandas I can explore my data set. That all will come under exploratory data analysis. So if I were to, take some points under this or write some points, I might write what are the numerical features, what are the categorical features, and what are some of the missing values. So let us understand each of this, step by step. So first we said we need to have a good knowledge on the basic libraries. Okay, we need to know NumPy, we need to know Pandas, we need to know the visualization libraries. Then we said you should start exploring your data set. So as you know the Pandas, NumPy, all those libraries, now you can start exploring your data set using these libraries. So firstly you need to find what are the numerical features. Numerical features as in what features in my data set are purely integers or float values. That is basically numerical features, and categorical features are nothing but what values in my data set or what features in my data set are some string value. String value could be, for example, gender. So the gender value will always be male and female, right? So this male and female are not numerical features, they are categorical features. For example, in your numerical features, you could have a column maybe or a feature saying height, and height will always be a numerical value, right? It can't be a categorical value. The third point which is mentioned here is missing values. So it is important to note that whenever you apply a machine learning algorithm in your data set should not have any missing values, right? So the easy thing would be to say is, okay, these are the missing values I have. Let me just drop them, right? Let me just drop them and it will make my job easier. But what turns out to happen is that just by dropping the missing values, you do not achieve a good rate or good accuracy percentage, right? So it is important that we deal these missing values with some other value. So we replace this missing value with some values. So in EDA, we are not going to do that. In EDA, we're going to just find out what are the missing values in some particular data set, right? So EDA just does not involve these three things. I've just written these three things as these three things are going to be very important in terms of feature engineering, right? So I guess the EDA part would have already been covered by now. So, uh, you already must be knowing a lot of things that we do in EDA, but these three things are definitely very important. The third step would be just derive from the second point, and that is handling the missing values. How do you handle the missing values? One important question. So the way you handle the missing values is replacing them by the basic statistical method that every kid in it will know. If you have done class 10, obviously you have. So that is by mean, median, and mode, right? So you have your mean, you have your median, and you have your mode, right? So these are the three basic ways where you can handle the missing values. Although there's a lot of concepts involving how to handle the missing values, right? So let me just make a note of that after I explain these three things. So where do we use mode? Mode will be used when you have a missing value in a categorical feature, right? So obviously, when you have a category, you cannot replace it by the mean or the median, right? So the mean or median you can only calculate if there are numbers. You cannot calculate mean or median for a category, for a character. So for numerical missing values, you can use the mean, median, mode, numerical features, right? So actually, there's some science behind missing values. So how are these missing values categorized, or how are these missing values related? Let me just note a few points down, and I would love for you guys to explore on this. If any of you are interested more, then we could send out some reading material for you to understand about these things. So the first way how the missing value is categorized is basically into MCAR, secondly MAR, and thirdly MNAR, right? So what this MCAR is basically nothing but missing completely at random. This MAR refers to missing at random, and this MNAR is nothing but missing not at random. So primarily, we can say that your missing value is because it belongs to one of this category. Either the missing value is because it is just missing completely at random, right? It is just missing at random. There's no science behind it or there's no logic behind it. It's just missing at random. Missing completely at random. So this word completely at random. Then I'll come to the third first. Then it is MNAR, that is missing not at random. It is just not missing randomly. There's something behind it. There's some logic behind it that it is missing. But this could, one of the example of this could be that there's a saying that women tend to to be shy when disclosing their age. So this could be one of the reasons. So this could fall under missing not at random. So So these things have, as I said earlier, these things have some logic behind it, and there are some leading material out there which will tell you that why this is the case, or why it is missing completely at random, why is it just missing at random, and why is it missing not at random. So there's actually some science behind it, and if you people are more interested towards this, the more scientific aspect or logical aspect of this, we could definitely share some reading material. But as of now, for handling the missing values, you could just remember this three basic statistical thing, that is mean, median, and mode. We will replace the categorical missing value with the mode, and the numerical features will replace with the mean and the median. So to basically for missing values, we also use this term called as imputation. So the way or the process or the method by which one replaces any missing value is referred to as an imputation. So there are various imputation techniques out there. What in this video we are saying is we'll be doing using the mean, median, mode. So we'll use the mean imputation, median imputation, and mode imputation. So any method you use to replace a missing value is termed, a technical term to it is imputation. So this is the third step in feature engineering, is how do you handle the missing values, right? So I think things are pretty clear till now. The next step, what we would do is something known as feature scaling, right? So it is referred to as feature scaling. So this feature scaling is nothing but, let's say I have a feature in my data set, and the values inside this feature is not, not in a linear manner, or not in a normal order. There's this complete change in the values. Let's say there's one value which is let's say there are 10 rows, and in the values present in the 10 rows can be 7, 8, 11, 12, 15, 16, and out of nowhere there's one value 200, or there's one value which is in negative. So it is important that we scale these features. So feature scaling is nothing but converting these values between some range. So what this does is it will improve the accuracy of your machine learning model, whichever you apply. So it is important to note that this feature engineering is the last step in, you can say, kind of in data science. So after this, you will be completely handling machine learning algorithms. So this is the last step where you will be, playing around with a data set. After this, all you will be doing is applying models, algorithms, and just trying to increase the accuracy. So in order to increase the accuracy, you will be playing around the data set. But this is kind of the last step where you will be doing all this exploring part of the data set, right? So how this feature scaling can be, we can obtain or do it is by using these two methods. This one method is standardization, and there's another method which is normalization, right? So once we do the practical aspect of this, I think this could be very clear. So again, there are various techniques to achieve feature scaling. As I said, just to avoid any confusion, feature scaling is nothing but making sure the values in a particular feature are scaled down to some range. So if you want the values present in the data set of a particular feature to be between -1 and 1, we can do feature scaling, right? So what will happen is if the values are, extreme and some values are almost on the similar range and some values are below the range, in order to avoid this, we will be doing feature scaling so that the values are in a fixed range. So what this will do, this will improve the accuracy of the model, improve the accuracy of the machine learning model. So this was the fourth step, that is feature scaling. Now let's look at the last step of feature engineering, and this is also a very important part, and that is converting your categorical features, converting categorical features to numerical features. So once you apply any ML model, before you apply any ML model, you should make sure that your data set is free from any categorical feature. So let us understand this with one example. Let's say you have a data set in which there is a gender feature or a gender column, and this gender column obviously will have value male or female, or it might have a missing value. So from the previous point, we come to know that whenever we have a missing value and it is a categorical feature. So gender in our example is a categorical feature. So whatever missing value we have, we will replace it with the mode. So once you do that, okay, the problem of the missing value is out of the picture. We don't have any missing value in our gender category. Now what we need to do is we know there are only two values, either it's going to be male or female. But once you apply any model, there cannot be something like male or female. These categories need to be converted into some number. So in order to do that, or in order to convert the categorical features into numerical features, we'll be looking at a technique which is called as an encoding. So this particular technique or this particular process, in order for you to achieve converting categorical features into numerical features, is encoding. So let me just write that. Converting categorical features to numerical. This is achieved by encoding. So primarily, there are two types, the basic two types of encoding techniques. There are a lot of techniques out there, but I, as per my knowledge or as per what I know, there are primarily two. There are more, but these two are pretty common. So first is one-hot encoding, and second is label encoding. So one hot encoding is nothing but, as we said, both of these encoding techniques, what it will do is it will convert the categorical features into numerical features. And one hot encoding can be achieved either via library, another library, which I have not written on top of that, is from sklearn. We will import pre-processing, or we can use the pandas function, that is get dummies, get underscore dummies. Using get underscore dummies also you can do one hot encoding, or you could also import from sklearn you can import pre-processing. And label encoding similarly you will be using sklearn itself. From sklearn you're going to import pre-processing. So once we get into the practical aspect, I think we will be looking at label encoding and one hot encoding. After this, it is important to know that actually you don't need to memorize the code for any of this encoding technique or this feature scaling. So if you just type it out or Google it, you'll mostly find Geeks for Geeks or any of certain of these websites which would have given an example, and have will have the code for that particular example. All you need to do is just copy paste the code and just change the features according to your dataset. So whatever according to what your dataset requires, you just need to change the variable names or the features names or whatever you want. So it's nothing like you writing the code from scratch. Everything is there, everything is available in the library. All you need to know is applying the correct feature or applying the correct method in order for you to get high efficiency, right? Ultimately, what matters is that whatever you do should be having the correct functionality. It should be as you expected or as the project expects. So these are the basically the five steps or five procedure you might need to follow under feature engineering. So this is the last step before we apply any machine learning model. So in order for you to achieve a high accuracy, you need to make sure that you do this feature engineering. So lastly, just one simple diagram or point is for you to understand is what we're doing is we have a raw data, we do EDA, then after doing EDA, you handle missing value, or you can say clean data. In clean data, you will handle the missing values, you will do the scaling, feature scaling, or you will do encoding. What you get is a clean data set. From raw data set, you get a clean data set. And to a clean data set, you can apply any algorithm, ML algorithm, and you get some prediction, right? So this is what we're trying to do. Through the basic libraries, you understood how can I import my raw data? How can I, what can I do with my raw data? What kind of analysis I can do with the raw data? So you do that, you export the data set. Once you export the data set, okay, I know what are the features, what are the categorical features, what are the numerical features, what are the different plots or charts using matplotlib you have done. After that, what you do is you clean the data, you handle missing values. This is where the feature engineering comes in. So you have done your EDA, you will do the handling missing value ka part. After that, you'll do your feature scaling. After you do the feature scaling, you'll do the encoding. So you'll make sure there is no categorical features. All the categorical features are converted to numerical features. After you do that, you get a clean data set. So after you complete feature engineering, your data set is ready for algorithm. So after that, apply any ML algorithm. After you apply any ML algorithm, you'll get your prediction or your accuracy. Prediction slash accuracy. So this is the basic outline of what you will be trying to do whenever you get a ML project, right? And this also basically concludes our video or the steps we need to follow for feature engineering. So if you have any questions, you can please feel free to reach out to any of us or you can drop in a comment. I hope things are clear. This is my first video. Amitabh must have handled all the videos before now. This is my first video. So if you have any doubts, please do let me know. Um, if possible, I will try to share this notes if it kind of helps you. Okay. Thank you so much.